All right, geometry students, here we are for section 7.5, the last section that we'll be covering in chapter 7. So let's go ahead and get started on the vocabulary that you already finished before you pressed play on the video. Circle the model that can form a proportion of 10/15. All right, so 10/15, we know that reduces to 2/3, right? That reduces to 2/3. So what other one also reduces to 2/3? That would be this guy right here. 4 out of the 6 are shaded, so that reduces that. Circle the ratio that can use to form a proportion. All right. These here we can use to form a proportion. They're equal to each other, so we can set 3/4 equal to 75 over 100. Cross out the proportion that does not have the same solution as the others. All right, which one does not? So just look at the cross product. There's 17n, 17n, 17 times 20. Oh, something's wrong, 17n. All right, so this is the one that does not have the same cross product as the others. Okay, all right. Next, a bisector. A bisector divides a whole into 2 equal parts. We know what a segment bisector is. We know what an angle bisector is. Bisecting it into congruent parts. A bisector is a point, segment, ray, or line that divides an angle or segment into 2 congruent angles or segments. Use the iron right and complete each sentence here with the correct word, or correct form of the word. Segment or ray BD. Ray BD is the what of angle ABC? That is the bisector. Angle ABC is bisected by ray BD. And ray BD bisects angle ABC. Okay, side splitter theorem. Side splitter theorem and its corollary. The side splitter theorem talks about sides of triangles, proportions. It's not because it's hilarious. The side splitter theorem says if a line is parallel to one side of a triangle and intersects the other 2 sides, then it divides those sides proportionally. So if the line RS is parallel to line XY, then XR over RQ is equal to YS over SQ. Okay. If XR is equal to 4, then RQ is equal to 4, then YS is equal to 5, and SQ is equal to 5. All right. So if it cuts it, in that case, into congruent parts. So that would be if R and S were midpoints, which means I would have a mid-segment of a triangle. All right, remember that from section 5.1. But now, if it does, R and S don't have to be midpoints. So now instead of cutting them equally or congruently, now we're going to be just cutting them proportionally. So if XR is equal to 3 and RQ is equal to 6, so XR, this is 3 and this is 6, you can see that the ratio is like 2 to 1, right? If YS is 4, then this guy's got to be 8. Okay, so it has a ratio of 2 to 1 or 1 to 2, depending on how you look at it. Okay? The corollary to the side splitter theorem says if 3 parallel lines intersect 2 transversals, then the segments intercepted on the transversals are proportional. So now, just instead of this figure right here finishing up here to make a triangle, all right, now I just have like the sides of the triangle that haven't come together yet. That's how you could think of it, okay? So what's happening this time is we have segment AB over segment BC is equal to segment XY or segment WX over segment XY, all right? So that would be AB over BC is equal to WX over XY. All right. Let's look at number 9 here. So how else can I write the proportion? The other way I can write proportion, think about the cross product. All right, the cross product here, BC has to multiply by WX. So Wx has to be here. So notice here, all we did was do the reciprocal. That's one of the reciprocal properties, right? All right, next I have to have, let's see, not only does it look reciprocal, but the names look like they've been flipped. All right, so the letters have changed spots. You got to make sure they line up. So it's going to be CV. And then if you look here, number 11, it says AC over AB. AC is the whole thing, right? That's the whole thing. The whole thing here is WI. All right, so WI has to be there. And that follows that property of proportions that if I took BC over AB is equal to XY over WX, right? Remember, we can add AB to the top and add WX to the top, right? We're allowed to add the denominator to the numerator, add the denominator to the numerator, and that proportion is still true. Well, this kind of shows how that works, because now if I look, if I take these and add those together, that's simply just going to be AC over AB. And then here, if I add these together, that's simply just going to be the whole. Instead of doing part plus part, we just do it with the whole over WX. Okay? So that's a good way to show why that property works. Using the side splitter theorem, what is the value of A in the diagram at the right? Value of A is found below. Use one of the reasons in the box to justify each step. All right, so it is done here for us. So you can see what we have set up. This portion, A over A plus 4 equals 12 over 18. Okay, so that's set up by using the side splitter theorem. All right, next, what are we doing? We're cross multiplying, right? Cross multiplying here, put parentheses around there so don't forget to distribute. Cross multiply there. Okay, so that is the cross product property. All right, next, we want to start solving for A, right? So we're going to subtract 12A to both sides. So that is the subtraction property of equality. All right, and then we're simplifying. What am I going to do now to get 6 out of there? Right, we divide by 6 on both sides, right? So that's going to be the division property of equality. And then finally, just take that guy right there and simplify it. There we go. Good. All right. Go ahead and pause the video and try this one here on your own. Pause it. Okay, so let's take a look and set up the side splitter theorem. So if I split the sides proportionally, I'm going to have Kp over Mk is equal to Ln over Ml. So now if I substitute in those values, I'll have x plus 1 over 12 is equal to x over 9. Okay? Now we'll go ahead, cross multiply and solve. Parentheses around a quantity, so I remember to cross multiply. Remember to distribute. So that gives me 12x is equal to 9x plus 9. Subtract 9x. That gives me 3x is equal to 9. Divide by 3, and x equals 3. All right? So it just says find the value of x. So we know that that is 3. We can bubble that in over here like that. Okay? Now, from experience and doing this live in person, I know that there's someone who always asks, well, I set it up differently and got the same answer. Let's think about what would happen if I took these right here and swapped spots, right? So it looked like this. X plus 1 over x equals 12 over 9, right? Do I get the same cross product when I cross multiply here? and here? I do, right? If I cross multiply here, I get the same thing. So all I did was switch the means right there, right? So if I switch those, nothing happens. I get the same thing. So in the side splitter theorem, if you are more inclined to think of it as this way, like 12 over 9 equals x plus 1 over x. Or you can think of it from the sides. X plus 1 equals 12. X plus 1 over 12 equals x over 9. I did it first. So you can think of it from side to side or up and down. Either way, it's mathematically equivalent. All right, find the length. 3 campsites are shown in the diagram. What is the length of site A along the river? So I want to figure out the length of site A, which is right here. That's what we want to figure out. Okay? So I'm going to look at one of the sites here that I know both measurements. And this site right here, I know 7.2 and 8. Right? So I'm going to use those to set up a proportion to help me solve for the missing one in that site right there, the missing side. Okay? So let's set up a proportion. How can we do it? Well, how about x over 8 equals 9 over 7.2? Now, you may have thought of setting up that a different way. If you thought of a different way, go ahead and write it down and see if the cross product is the same as the one that I have up here. And it should be. Okay, so if I cross multiply here, I'm going to get 7.2x is equal to 7.2, or 72. Right? And if I do 72 divided by 7.2, what do I get? 10. All right? I get 10. So divide by 7.2, I get x equals 10. So 10 yards is going to be my answer. Okay? All right, go ahead and pause the video and do number 2. Find the missing piece on site C, which is this side right here. We'll call that Y. So pause it and go ahead and solve for Y. Okay, so we can use the same proportion as we did last time. All right, we could say, how about 8 over 6.4? Not the same proportion, the same ratio, I mean, using the blue site. So 8 over 6.4 equals 7.2 over Y. All right, now again, I know that might be different from than what you had, all right? But as long as your cross product is the same, then you're good. So as long as you have 8y is equal to 6.4 times 7.2, or 8y is equal to, let's see, 6.4 times 7.2, 46.08. All right, now divide by 8. Divide that by 8 and get 5.76 yards. Okay, so there's our answer. Okay. All right, any questions with that? All right, good. Again, as long as your cross product is the same, then your thought process and how your brain works to set up a proportion, all right, can be up to you. All right, next theorem. Next theorem we have here, 7.5, triangle angle bisector theorem. Triangle angle bisector theorem says if a ray bisects an angle of a triangle, then it divides the opposite side into 2 segments that are proportional to the other 2 sides of the triangle. So if I look at what this says right here, oops, sorry about that. It says if the ray BD bisects angle CAB, then we have CD over BD is equal to CA over BA. All right, so that would be this over this is equal to this over this. All right, now there's a little bit different way that I like to do this, and all it does is switch these, and it's equivalent. We know we're allowed to swap those spots, and it's equivalent. All right, and it's a simple pattern to do. if I follow the bisector, all right, to where it hits this opposite side, which is at the point D, and go back around to the angle that was being bisected. So that is DC over CA is equal to, now do the same thing the other way, BD over BA, or DB over BA. All right? This is how you're going to see me set it up. And you can see it's the exact same thing that's here. All I did was swap those, right? Which we know we're allowed to do as long as the cross product is the same. Okay? So that's how you're going to see me set it up here in this next example. All right, so I might skew a little bit from what the book has here. What is the value of y in the diagram at the right? Okay, so we look for where the point, where the angle bisector hits the opposite side, right? And then I write it as 9.6 over y is equal to 16 over 24. That's it, all right? That's all we need to do. Now, if you look, what is over here, what should be in that box? What's going to multiply by 9.6? That's going to be the 24. And you can see when I cross multiply here, they're the same thing, right? So the notes here show it just a little bit different way of thinking, but in the end, you get the exact same thing because the properties of the proportions come out to be the exact same thing. All right, so if I cross multiply here now, so I would get 9.6 times 24, all right, which is going to give me 230.4. Divide both sides by 16, it would be 14.4. All right, so the value of y will be 14.4. All right. Okay. Okay, go ahead and try this one on your own, and then we'll talk about it together. So pause the video. All right, so the first thing I want to do, as it says, is to write a proportion. So I'm going to go to where this point, all right, from the angle bisector hits, which is Q. So I'm going to have 10 over 12 is equal to 18 over X. All right, simple. Okay. Actually, it said do the proportion here first. So if I do that, that's going to be QR over RP is equal to QS over SP. Now we substitute those in. We kind of did that backwards. That's all right. Now we'll cross multiply. 10x is equal to 12 times 18, which is 216. Divide both sides by 10, and x is equal to 21.6. All right? There's our value for x. All right. That brings us to the lesson check for the day. Go ahead and complete both lesson checks, please. And then all the way through the math success on that last page. So pause the video and complete the whole lesson checks, both of them. Go for it. What's the value of x in the figure at the right? Circle the proportion you can use to solve the problem. All right, what proportion can we use to solve the problem? Well, notice what we have right here is we have this whole side of 45. I don't have this whole side, but I could write it as x plus 10, right? So if I do a part over the whole equals a part over the whole, that works, which is that one right there, right? So let's go ahead and solve that. So we put parentheses around here so we don't forget to distribute. That's going to give me 450 is equal to 30x plus 300. I'll subtract 300 from both sides. That's going to give me, 50? 150, excuse me, is equal to 30x. Divide by 30, and I get 5 is equal to x. All right. So x is equal to 5. Okay? Questions with that? All right, another way that you could think about doing this problem is part plus part equals whole, right? So if the whole thing is 45 and this part is 30, then that means that this little part that's left is 15, right? Okay, so I could do x over 10 equals 15 over 30. And that gives me the same thing in the end. 30x is equal to 150. Divide by 30, x equals 5. Okay. This one that we did first, it just uses what we're given rather than trying to find something first to use. Okay. Okay, let's look at the second lesson check. A classmate says you can use the side-square theorem to find both x and y in the diagram. Explain what's wrong with your classmate's statement. Cross out the lengths that are not part of sides intersected by parallel lines. That would be 7 and x. This side of 7 and this side of x are not sides that are being split. So if they're not sides that are being split, you cannot use the side-splitter theorem to find x. What about to find y? Could you find y? Yes, you can use the side-splitter theorem to find y because y is part of a side that's being split. So explain what is wrong with your classmate's statement. X is not part of a side that is split. Okay? So you can't use the side-splitter theorem. The other way to think about it is that x is not part of the transversal, all right? Or x is not part of a transversal, right? If these are my two parallel lines and this is my transversal, y is part of the transversal, right? X is part of the parallel line. So that's the other way to look at it. All right, so here's what I'd like you to do now is go ahead and solve for x and y in this figure. So pause the video. All right, go ahead and solve for x and for y. You should be able to solve for y based on what we learned today. You should be able to solve for x based on stuff you've already known from over the whole chapter. All right, so pause the video and solve for x and y. All right, let's go ahead and take a look here and solve for y here first, because I can do that by what we did today. All right, we can do 2 over 3 equals y over 2.4. Or however you set up your proportion is fine, as long as the cross product is the same. So I'll get 3y is equal to 4.8. All right, divide by 3, I'll get y equals 1.6. Okay. Now, how about x? Well, as we said when we finished this problem, x is not part of a side that's being split. However, what we have is we have two similar triangles. We have that triangle right there, and then the big triangle has a side of 5, right? And a side of 7. So we can set up a proportion and do 2 over 5 is equal to x over 7. Cross multiply, I get 5x is equal to 14. Divide by 5, x equals 14/5. All right. You can leave it as that improper fraction, or go ahead and get a decimal approximation of it, which would be 2.8. Okay. Bisector. You know what a bisector is? Cuts into two congruent parts. Proportion. When a ratio equals a ratio, and the side splitter theorem is going to take the sides of a triangle and split two of them by using parallel lines proportionally. Okay? All right, put a dot on the line on how well you understood today's material, and you are now all set to go ahead and work on the assignment. Okay? All right, go ahead and do that, and I will see you next time.